Hi there. We're now going to see how to calculate the variance and the standard deviation of the example we gave in the last video. If you remember, the example in the last video had a situation where during the first year I was managing your money, I earned a 5% return. The second year it was 9%. The third year I lost 12% of the money. The investment was down by 12%. And then the fourth year was 20%. We said, okay, if we add those numbers up and then divide by 4, that's an average return of 5.5%. What we want to be able to see, though, is not just the average, but what amount of volatility there was in those returns. Volatility is going to be how much we're going up, and sorry about that, knocking the microphone there, how much we're going up above the average and how much we're going down below the average. A little bit of volatility means we're going up and down like this. A lot of volatility means we're going way up and way down. Okay. So first of all, we have to establish what that average is, and that average is 5.5%. So what we do is we take each of the data points and we measure how far away they are from that average of 5.5%. The first data was 5%. So when you measure distances from something, you take one and subtract it from the other. Now, to calculate variance, it's easier to do this in decimals rather than as percentages. So if you're taking a look at page 3 of the notes for this, you'll see that the variance, which is given by the Greek letter sigma squared, is going to be first 0.05 minus 0.055, and then that's squared. So the 0.05 minus 0.055 is saying how far away is that first data point, 5%, from the average of 5.5%. Okay, so 0.05, or 5%, minus 0.055, 5.5%, what's the distance there? Then we square it, okay? So this is going to make all the numbers positive, which is what we want to be able to see on this. And then we add to that the next data point, how far is it away from the average? So that's 0.09 minus 0.055. Again, we square it. That has the benefit of, again, turning these all into positives. Next one, how far is it away from the average? The negative 12% from the average of 5.5%. So that's negative 0.12 minus 0.055. Square that. And then the final data point was 20%. So 0.2 minus 0.055. Square that. So now we've got for each of our 4 data points, how far they are away from the average, from the arithmetic mean. We have squared each of them, and we've summed them together. That's in the numerator. Now in the denominator, what we want to do is we want to put down how many of these there are. In this case, there was 4. It's important to understand that if we're trying to calculate the variance of these 4 years, we have all the data and we can do it, and we divide by 4. However, if we are trying to calculate the variance of my ability as a money manager, and I might be managing more money in the future, or perhaps I was managing more money in the past, and these 4 years are but a sample of my time as a money manager, now we don't have all the data, and we can't calculate the variance. What we can calculate instead is what's called the sample variance, or an estimate of the variance. When you don't have all the data to be able to calculate the variance, or you're trying to calculate you only have a sample of that data, you no longer divide by n, the number of data points you have, which was in this case 4. You would divide by n minus 1, which is going to be 3. So we're going to assume that we have all the data, that these 4 years is what I want to find the variance of. We don't want to find the variance of my total ability as a money manager. So we're going to divide by 4. When you do that, you get the variance is going to be 0.013225. And again, we usually leave that as a decimal. It's not wrong to turn it into a percentage, but variance in finance is usually expressed as a decimal, because we're going to end up taking the square root of that and then expressing that as a percentage. Standard deviation is the square root of the variance, and it's just a little bit easier number to work with sometimes. So when we take the square root of 0.013225, that's 0.115, or expressed as a percentage, 11.5%. So now we can say that during these 4 years that I was managing the money, the average return was 5.5%. The Variance was 0.013225. The standard deviation was 11.5%. And the geometric mean for managing the money those 4 years was 4.85%. Now, we're going to be using all of these in finance, and it's important to understand what are the differences between them and exactly what are they measuring. If you've had statistics in the past, this is second nature. You know all this stuff. If you haven't had statistics, though, it might be a good idea to make sure you review arithmetic mean, geometric mean, variance, and standard deviation. Well, that's what we're going to be dealing with those in the future, and that's going to be it for what we're doing right now.